Okay, let's review. We've learned about the basic parts of the sun. We've learned how research scientists study the sun with different types of light radiation.
We've also learned that satellites provide us with this information.
Right, but what if we could see the events leading up to solar storms? Dr. Michelle Larson from the University of California at Berkeley has the scoop.
What is the goal of the HASB satellite?
When do solar flares occur on the sun?
How do solar flares have a direct effect on the Earth's atmosphere?
Hi, I'm Michelle Larson and I'm an astrophysicist. An astrophysicist is a researcher who studies physics in space. I'm here at Vandenberg Air Force Base in California with the HASB satellite. Let's take a look. HASB, or High Energy Solar Spectroscopic Imager, is designed to learn more about the basic physical processes that occur in solar flares. Teams of astrophysicists and engineers work together to decide what kinds of observations HASB will make and what kinds of scientific instrumentation will be required. The HASB teams will achieve their goals by taking pictures of solar flares in the X-ray and gamma ray radiation range.
What is a solar flare?
Well, remember when Eric told you that solar flares are the biggest explosions in the solar system? A solar flare occurs when magnetic energy that builds up in the solar atmosphere is suddenly released. Charged particles, such as electrons, protons, and heavier ions, travel away from the sun along magnetic field lines. Others move towards the surface of the sun and emit X-ray and gamma ray radiation as they slow down. Flares produce all forms of radiation, from radio waves and visible light to X-rays and gamma rays.
Why study solar flares?
The biggest flares are as powerful as billions of hydrogen bombs exploding at the same time. We still don't know what triggers them or how they release so much energy in such a short time. But solar flares have a direct effect on the Earth's upper atmosphere. For instance, long-distance radio communications can be disrupted by the effect of flares on the Earth's ionosphere that is a part of the Earth's atmosphere. In addition, energetic particles accelerated in solar flares that escape into interplanetary space are dangerous to astronauts outside the protection of the Earth's atmosphere and magnetic field, and also to electronic instruments in space.
Where do solar flares occur?
Solar flares occur in the solar atmosphere. Inside a flare, the temperature is roughly 10 times hotter than the corona and can be as high as 100 million degrees Celsius. The frequency of solar flares varies with the 11-year solar cycle. At solar minimum, very few flares occur. As the sun approaches the maximum part of its cycle, they occur more and more frequently. Let me show you on this graph. Let's look at the graph of actual solar flare data from 1990 to 2001. The title of this graph is Number of Solar Flares versus Years. The horizontal axis, or x-axis, represents years, and the vertical axis, or y-axis, represents the total number of flares recorded. From the graph, we can see that we have a solar maximum in 1990 and one in 2001. We have a solar minimum at some point between 1995 and 1996. This graph shows us that the sun does have a solar cycle, which is about 11 years. From this graph, we can predict when the next solar maximum and minimum will occur.
How do you study solar flares?
Well, it's actually very difficult to study the high-energy X-rays and gamma rays emitted during solar flares. To solve this problem, HASB uses a very unique method. HASB will obtain pictures of solar flares within the X-ray and gamma ray range by using pairs of metal grids to cast shadows onto detectors. Each grid is a bit like a fine screen, but with lines running in only one direction, like jail bars. The solid slats block radiation, and the open slits allow radiation to pass through. As the satellite rotates at about 15 times per minute, the grids will allow high-energy X-rays and gamma rays from different parts of the sun to sometimes pass through and sometimes not, depending on how the slats are oriented. The HASB detectors will measure the energies of the X-rays and gamma rays that get through and will record how things change as the satellite, and therefore the grids, rotate. This is enough information to figure out where the radiation came from on the sun. This information will be transmitted to the ground, where HASB scientists will use it in their computers to make pictures of flares in X-rays and gamma rays. It is like putting together the pieces of a puzzle to figure out what the picture is. The special way HASB will measure high-energy radiation from the sun, combined with the way scientists will analyze the data, will allow us to study the sun in a way never before attempted.
Why will HASB observe the solar flares in the X-ray and gamma ray range?
We know that light emitted in the X-ray and gamma ray range shows different events than that emitted in the visible light range. High-energy X-rays and gamma rays carry the most direct information available about the energetic particle activity on the sun that occurs in solar flares. With the help of HASB, we will be able to anticipate solar flares. And HASB will aid in understanding energetic events throughout the universe.